Dr.Ashwin Dobariya welcomes you to Programming in C video series. In this practical video, we will discuss the program of Armstrong number. In this program, we will input one number and the program will check whether the input number is Armstrong number or not. So let's first we discuss about the logic of this program. The definition is like the program which takes input of a number and check whether that number is a Armstrong or not. So first of all, friends, you should aware about the logic which number is known as a Armstrong number and what is the logic of that Armstrong number. So here I have given one example. Suppose your input number is 153. So 153 is an Armstrong number or not? How we can know that? So the logic is like that. The first steps we have to separate each and every digit. So here there are 3 digits in this number, 1, 5 and 3. So first steps is we have to separate the digits. Then after we have to calculate the cube of the each and every digit. So cube of 1 means 1, cube of 5 means 125, cube of 3 means 27. And after that we have to calculate the sum, and if that sum is equivalent to the original number, it means both are equal, then this input number is Armstrong number. So this is the overall concept. In this video we will discuss the practical how we can write these Armstrong number programs in the C language. Let's see the overall logic first we will discuss. The first steps what we have to do in this program. So first we have to input one number. So that number is a whole number. So suppose 153 is one input number. That is the first step. Second step what we have to do, we have to separate each and every digits. How we can separate? That logic we already discussed in our previous video. If we want to separate the digits, then we have to divide these number by 10 and not using the division operation, but we have to perform the modulus operations with the 10. So modulus operation with the 10 number is always written the remainder, and remainder is always a last digits. So in that way we can separate that. Then third steps we have to calculate the cube of each and every separated digits, and after that we have to calculate the sum of each and every cube, and that sum we have to final steps we have to compare that sum with the original number, and if both are same, then this is the Armstrong number. So these are the steps that we have to write in the programs. You consider that is just like the algorithm kind of things, which are the steps we have to do in this program. So first of all, let me just consider how many variables we require in this program. So definitely the first variable, that is input number. For example, num is a variable. Then sum we have to calculate of the digits. Then the sum is an initial value is 0. Then to separate the last digit means each and every digit, the remainder, the variable is r, and temporary variable we have taken because at last we have to compare our original number with the sum. Then we know that here original number we are converting in a we are separating one by one. So how we can access the original number? So we will take one backup copy of original number into temporary, and let's we execute these programs one by one. And here I also mentioned the dry run table over here. As we already discussed the 80% logic in our previous video, like to reverse the numbers and the palindrome programs. If you have not seen these videos, please friends, you also view that. The link is given in this video description part also. Now suppose our input number is 153, then while this loop we want to continue till the number becomes 0 or the numbers is greater than or greater than 0. If number is greater than 0, up to that we have to execute this loop. So first time the input number is 153, so number is 153 is greater than 0, condition becomes true. Then how we can separate the last digit? Then number we will perform the modulus operations with the 10. So it will give the last digit. So 3 will be written and it will store into the R. Initially the sum value is 0. So sum value is initially 0 plus the last digit is stored in R. So we have to calculate the cube of the each and every digit. Then cube of 3 means 3 multiplied by 3, it's a 27. 27 plus 0, it becomes 27. So sum is now 27. Now how we can separate 5? So for that we require 15. Then how we can make this value as a 15? So 153 divided by 10. Actually we know that the answer is 15.3. But num is also integer, 10 is integer, then it will ignore 0.3, so it will return only a 15 and it will override in a num variable. So the latest value of num is 15. Again the loop will execute second time. Now it will check 15 is greater than 0. Yes, condition becomes true. Again the latest value of num is 15 modulus 10, then it will give a last digit 5. 5 will be stored into r. So now r value is 5. Now what is the last value of sum? 27 plus the cube of r, latest value of r is 5. So 5 multiplied by 5 multiplied by 5 means 125. 125 plus 27, it becomes 152. So the latest value of sum is 152. After that again 15 divided by 10. So 15 divided by 10, it gives 1.5, but again 0.5 will be ignored, so it will store only 1. So now the latest value of num is 1, and again the loop will execute whether num is greater than 0. Yes, 1 is greater than 0, then 1 modulus 10. Now the number is less than the divisor, then the number itself return as a remainder. So the latest value of r is 1, then the old value of sum is 152 plus the cube of 1 is 1. So 152 plus 1 is become 153. So now the latest value of sum is 153. Now the num is 1 divided by 10, it gives 0.1, but 0.1 will be ignored, then it gives only a 0. Now what happened? Next loop, 0 greater than 0, the condition become false and control transfer outside this loop. Now outside this loop we will check the final conditions. Now we know that the sum of all the cube digits is available in sum variable, and the sum variable we have to compare with our original value, and we know that the original value backup copy we have stored in TMP. So after this loop we will compare whether temporary means original number is equivalent to sum. If both, now see here, sum and our original number both are equal, so it means 153 is the Armstrong number. So this is the logic of this Armstrong number program. Let's we execute in a turbo C. Here first we require two header file, stdio.h, conio.h. Friends, I have also given the link of this source code of this program in this video description part. You can download these source codes in your laptop or a desktop, and you can do the practical of this program. Here we have declared 4 variable, temporary variable, input number, sum and r. Then clear screen. After that we will ask the user to input any number. So if user input 153, then 153 will be stored into the num variable. After that we will take a backup copy of our original value into the temporary, because we are changing this value in a loop. That's why we have to take the backup copy in a temporary variable. Now in this while loop, first num modulus 10 will separate one by one digits from the right side, and then first we will calculate the cube and we will calculate the sum, and the num divided by 10 we will separate the last digits, and this loop will continue till the number becomes 0. Once this condition becomes false, then we will check the temporary means original number is equivalent to the sum. If it is there, it means condition becomes true, then the number is Armstrong, otherwise number is not Armstrong. Let's say execute this program, and if I input 153 and if say, then the input number is Armstrong number. But suppose if I run the program again and if I input 125, then this number is not Armstrong number. So in that way, friends, you can write this logic of this program. I hope, friends, you understood the logic of Armstrong numbers, and the source code of this program also mentioned in the description part of this video. Please download, and I have also given the other theory and practical video links in this description part for your reference. So please, friends, like this video, share with your friends so they can also get benefits. And friends, kindly give your feedback, suggestion in the comment of these videos. And in next video we will discuss the another program like a C program which takes input of a number and check whether the input number is a prime number or not. So like 11, 13, 17s are the prime number. Then what is the logic behind that? That we'll discuss in the next video. So for getting the updates of next video, please friends subscribe this channel. Thank you very much.